Okay, everybody. Well, hopefully the video we watched about what they've been doing in San Francisco for a while was sort of inspiring, and that fact that people can actually deal with this in a really positive way to try to figure out what to do with all of our waste products. And the last little bit of that video, you saw the composting that they were doing. And that's basically turning all the organic material, the food, the scraps, whatever yard debris, leaves, and that can be converted into mulch and humus. And that's a natural process. Compost costs a lot of money if you were to go somewhere and buy it. So the fact that the companies or these cities are actually making that and then selling it to the vineyards in California or to the farmers or to even landowners, that's a really good thing. So this could be used by organic farmers as well to enrich their soil, and that's a super great way of making sure that that material then gets reused instead of going into a landfill or maybe even into an incinerator. So let's talk a little bit about recycling. All of you have probably grown up with recycling. So the video showed you some of these recovery facilities, and locally here in Ohio, we have one that handles most of the debris from Cincinnati called Rumpke, and they use a series of machines and people to help separate out the different materials that come through. Some of these ways they can even separate out glass by the color of the glass. So then once it's separated, then at that point they can be recycled and made into new goods. And then the last step involves us accepting those recycled products and actually purchasing and looking for them that are made from these materials. This has grown really rapidly. And so locally, recovery has risen pretty sharply in recent years. And that's, although I gotta say I'm a little disappointed on the Middletown campus when we used to be there face to face together. Lots of times I would see students putting garbage into recycling bins and recycled materials into garbage bins. And so I think that just requires, a 30-second, if that, thought about where are you disposing of it and what does that mean. So if somebody throws something greasy or oily in a recycling container, it's possible, like let's say it's a bunch of paper or something, if you add a bunch of oil into that, then all of that paper is contaminated and none of it is recyclable anymore. So some of this is just care, right? Making sure that you put the right thing in the right place. And so it really is kind of interesting if you look at this graph to see what is being recycled, what's not being recycled. For instance, almost all the lead acid batteries, those would be the ones that people use in their cars. About 99% of those are recycled. And that's great because those contain a lot of heavy metals. The interesting reason why those are is because when you go to buy a new battery for your car, they ask you for your old battery. And if you don't have your old battery, they charge you something called a core charge. And that can be up to $25 if you don't have your old battery to turn in. So that's really made a big difference and made sure that those batteries then get recycled. Newspaper, cardboard, even yard waste and aluminum cans, we could do better with all of those kinds of things. There are some places that don't accept glass. And so not every area does accept glass, and there are lots of facilities that don't accept plastic, or they don't accept all plastics. So sometimes that isn't because people aren't trying to recycle. Sometimes that's because they don't have that available in their area. And, it doesn't really, you can, just because it has a recycling logo on something doesn't mean necessarily that your local recycling company will take that. So for instance, a good example of that is styrofoam. Lots of the styrofoam packing material will have the recycling logo on it, but locally in Ohio, none of the recycling companies have a market for it, so they don't accept it. So we need to really work on kind of expanding that and finding better uses for all these materials that could be recycled. There is this idea, and you saw that in San Francisco in the video, that they charge you based on how much garbage you throw away. And so they actually charge you per bag or per weight of the trash that you throw away. And that really has a great impact on people trying to recycle more and throw away less. There have been in the past bottle bills where you have to pay a deposit on glass bottles. When I was little, you would get a nickel a bottle if you returned them. And so lots of times people would go around and collect bottles and take them back to the store. And if you're a little kid, you can make a lot of money doing that. And so some states still have bottle bills, and they have a lot more recycling going on for those glass bottles than states that don't have those at all. And so this is a video about what Rumpke will recycle. I'd like you to review that and make sure that you know what you can throw away and what you can't throw away. That the bottles and jugs thing is a little confusing because so many things do have a recycled logo on them. So basically, Rumpke will take any kind of plastic bottle or jug if the opening is smaller than the rest of the container. That's how they use to decide if it's the kind of plastic that they can recycle and sell. So for instance, if I look at those pictures, you can see all of the the milk jugs and the pop bottles and the water bottles, they all have a smaller opening. Something that I thought that you could recycle, you can't, like a plastic like mayonnaise bottle. It's got the same size opening as the rest of the container, and all of the plastic containers that like lunch meat come in, cottage cheese, sour cream, yogurts. Even though they all have a recycling logo on them, Rumpke won't take any of those. So there's no point in recycling them. They just have to go then and pick them out. So I thought this was really an interesting video so you could see what could and couldn't be recycled locally. All metal cans can be recycled. All glass can be recycled. Certainly anything that's a carton, like a milk carton, a juice carton, any kind of paper, cardboard, all of those kinds of things can be recycled. So anyway, please watch that video. It's kind of interesting to see the inside of a recycling facility, to see how all that works. And again, the really big issue, why can't more things be recycled? It's because they don't have a market for them. You can't sell a recycled product for more than you would if it was made out of brand new materials. And so one of the other issues is how many different kinds of plastics there are. There's lots of different kinds of plastics. And so that makes it very difficult then when they're all mixed together. I mentioned to you already about contamination. So oil, grease, anything like that is a big contaminant in a lot of these recycled containers. Let's see if we can watch this. This is a short video about some very cool new startups that are using recycled products. I'm hoping it will launch and be in your field of view. Sorry, everybody. It's not cooperating with me at all. All right. I guess we can't watch that together. I know the link actually works, and so maybe you can watch that startup video on your own. There are a lot of interesting things that are being done with these new products. So I'm sorry, it doesn't seem to launch for some reason. So we're going to spend some time talking about what sanitary landfills actually are. They're actually fairly complicated, and it's not just like an old-fashioned dump where people used to just take stuff they didn't want and they dump it. That's not what a sanitary landfill is. These are highly engineered and monitored facilities, and the main goal here is to prevent waste from actually contaminating the environment. And so the law that governs how these landfills are opened and created and operated is through the EPA, and so they have the final jurisdiction on where a landfill can be run and how they have to be run. And so again, they are absolutely not just a dump. They aren't. And let's see if we can get this one to work, and hopefully we'll have better luck with this one.
Every day, we take out the trash. In fact, the average household generates about 50 pounds a week. Then, at businesses, manufacturing and construction sites, you soon realize we have a lot of trash on our hands. Studies have shown that more than half of our trash could be recycled, and we hope you use the curbside recycling or public drop-off boxes in your neighborhood. But where does everything else go? What happens after the Rumpke truck picks up the garbage? For most people, the garbage process ends at the curb. For Rumpke, it's only the beginning.
Enter sanitary landfills. Throughout the Midwest, Rumpke employees strive to protect our health and environment through the proper disposal of our non-hazardous trash. Years ago, one could simply dig a hole, throw some trash in it, cover it with dirt, and walk away. Times have certainly changed. Today, a team of Rumpke environmental engineers and professionals follow strict guidelines to design, construct, operate, and monitor our landfills.
Landfills begin with an appropriate location that meets certain requirements. For example, a landfill cannot be located within 1,000 feet of natural areas like parks and preserves. There are also restrictions near homes, wetlands, airports, and aquifers. After selecting a location, the landfill is divided into phases called cells, which will be prepared and approved to receive trash. What often begins as flat ground must be excavated. Blasting is sometimes required to remove rock and reach excavation goals, especially in areas with hard beds of shale and limestone.
Safety is a top priority for Rumpke. Each blast is recorded by seismic monitors placed around the facility. You may feel a slight rumble outside the blast area, but it's probably less than the impact of a slamming door.
After excavating the cell, we are still quite a ways away from accepting trash. Next, a series of protective liners are installed to ensure that everything placed in the landfill stays in the landfill. It all begins by placing a 3-foot layer of recompacted clay along the sides and bottom of the cell. Rumpke often uses clay from the excavation process for the liner. The clay acts as a natural barrier under the trash. Next, a synthetic liner is placed on top of the clay. This thick plastic material helps keep liquid from ever reaching the clay liner. It comes in large rolls, like carpet, and is rolled along the sides and the bottom of the cell. Then, the pieces are sealed together and pressure tested to make sure air and water are not able to pass through the seal.
We're almost ready. Next, we must collect and remove any liquid that accumulates in the landfill. We do so with the leachate collection system. Leachate is any liquid in contact with garbage. It's sometimes called garbage juice. The system consists of a geocomposite layer that is like a sandwich, with 2 pieces of geosynthetic fiber surrounding a high-density polyethylene plastic coil. The liquid is transmitted by the geocomposite to a series of gravel-covered pipes and powerful pumps. The pumps draw the leachate into a holding tank before it's transferred to the local sewer district for treatment. The gravel also serves as a cushion on top of the liners.
It can take anywhere from 3 to 5 years to construct a cell. We don't want to risk puncturing the liners, so sand or gravel is used as a protective layer. As a cell is constructed, the liners are continuously tested. Any issues must be corrected before waste placement can begin.
Finally, specially selected loads of trash are sent to the new cell to make what's called the fluff layer. The fluff layer is typically waste from households, so it's likely to include a lot of food scraps and paper waste, or fluffy stuff that provides additional protection for the liners.
Now the cell is ready for all the trash. Before the trash is unloaded, however, the trucks must be weighed at the landfill scale house. Each landfill has a daily or yearly limit established by the state's Environmental Protection Agency. The scale house operator gathers information such as the amount of trash in each vehicle and the truck's collection region. Rumpke creates daily logs and reports for various monitoring agencies, municipalities, and state government. For each ton of trash entering landfills, tipping fees, similar to taxes, are paid back to local, county, and state governments. The truck then travels to the active cell, or the working face, the area where garbage is being placed for the day. The driver waits in line until a clearing becomes available. Then, it's time to tip the load. Heavy equipment weighing up to 120,000 pounds, called steel wheel compactors, spread and crush the trash from 1/8 to 1/16 of its original size. This creates a safe work zone, conserves landfill space, and minimizes odors.
At the end of each day, the working face is covered with dirt and rocks, which reduces odors and stops wind-blown trash. It also helps prevent animals and rodents from lingering near the landfill. Keeping the working face covered is only one way Rumpke works to minimize odors and litter. Fences surround the landfill, and a dedicated litter crew work together to keep wind-blown litter where it belongs, in the landfill. At Rumpke's larger sites, a series of permanent and portable misters release an environmentally friendly odor-neutralizing agent designed to reduce trash and other operational odors. It's comparable to industrial-strength fabric and air fresheners. At all of our landfills, monitoring is key. Rumpke uses technologically advanced air quality monitors, in addition to groundwater monitoring wells, to continuously ensure optimum air and water quality at and around our sites. Not only does Rumpke use street sweepers and water wagons to help control dust, but even our trucks pass through a specially designed wheel wash to remove any trash from tires and the underside of the vehicle, keeping waste where it belongs.
After the garbage is placed in the landfill, something begins to happen to it: decomposition. In actuality, very little decomposition occurs in the landfill, but when it does, the process creates usable gas. To capture the gas, special wells are drilled throughout the site, and they extract the gas like a vacuum sweeper. At some landfills, the landfill gas is conveyed to a methane gas recovery facility, where the gas is converted to reusable energy, such as natural gas or electric. The landfill gas-to-energy facilities at Rumpke's landfills provide enough energy to power nearly 30,000 homes and businesses, making them some of the largest landfill gas-to-energy facilities in the world. Special conditions are required for landfills to make beneficial use of its gas. Until those conditions are met, some sites simply burn the gas with a flare. The burn rate is measured to ensure environmental compliance. Regardless, the gas wells are monitored to ensure they are working properly.
After filling a cell to capacity, a special capping system must be installed. The final cap consists of liners similar to those at the base, with layers of clay, plastic, and drainage components. Next, soil is spread, and grass is planted. Rumpke will then monitor the site for at least 30 years after it closes. Inspections will be done on the gas and leachate collection systems, and a general upkeep of the site will continue. After 30 years, the landfill can be reused for a variety of activities, such as a walking trail, park, or golf course.
Whether it's school, home, or work, we all produce trash, and we need a place to put it. Rumpke's sanitary landfills are engineered structures designed to protect our health and environment. We're proud of our facilities and invite groups to participate in tours and educational presentations. Since 1932, Rumpke has been keeping neighborhoods clean and green. Our humble beginnings as hog farmers during the Great Depression have grown to one of the largest privately owned waste companies in the world. With nearly 50 family members and more than 2,000 employees, we are dedicated to taking care of our trash and recycling one can at a time.
So the next time you take your trash can to the curb, know that with Rumpke, your trash is handled by a team of professionals,
working hard every day to protect your health and your environment.
Okay, so hopefully you paid a lot of attention to the video. I'm going to tell you ahead of time, this is going to be an essay question on your final exam. I basically want you to tell me how a sanitary landfill is constructed and some of the measures they make sure that so things don't leave the landfill. I'd like you to review that. So if you weren't paying such good attention, maybe go back and watch that video a second time. Here's sort of a diagram that sort of shows you again how these landfills are constructed. I'd like this essay that you're going to write to be in your own words. It has to be written by you in your own words. So explain to me, how do they make sure that liquid doesn't get into the aquifers or into the groundwater? What happens to that leachate that they collect, right? So another name for that leachate would be garbage juice. What happens to that? How do they deal with that? Why are they collecting the methane? So please review this and expect a pretty big essay question on your final exam about this. There's another picture, so in case you're not sure about it, you can go through and watch it and review this again. So this is really what we're using. Most developed countries are using sanitary landfills. This is our main disposal method. This is how we are handling our garbage, mostly in the United States. In the past, people did all kinds of things, including putting garbage on barges and hauling it out to the open ocean and dumping it. Most developed countries do not do that anymore. And this is a picture of Mount Rumpke. This is located near near Hamilton County, Ohio, near Cincinnati. And it's the largest landfill in the state of Ohio and the 6th largest in the United States. So I know a lot of people that maybe drive from Oxford to Cincinnati actually drive past Mount Rumpke. So there's a second video if you're still not sure about how these landfills actually operate. That video sort of shows you the history of how that landfill came to be. And so what happens when these landfills fill up? So closed landfills are actually usually converted into some kind of public area. And so one of the ones that I know about real well is called the Fresh Kills Park or landfill that was near New York City. You can see that over on the left, and you can see that with lots of restoration and reclamation, that's what it looks like now on the right. So this is what happens with these landfills. I've had the opportunity to help on some of these restoration projects. This is an aerial view of that Fresh Kills landfill. You know, it's an active wetland. It's made an entire just huge mountain of garbage now. It's made an entirely new ecosystem. And again, that would be a great example of reclamation and restoration ecology, what you see here. So sometimes some garbage is incinerated or burned. We talked about that when we were talking about biomass waste, or using biomass as an energy fuel. This can reduce the weight of the waste by a huge amount, by 85%. It can reduce the volume by 95%. There's a little YouTube video you can watch about how these incinerators work. Again, there are issues with air pollution if you just burn trash together. There's some concerns about that, but a lot of huge cities that just make so much waste that they just would run out of room and their landfill would close up too quickly. A lot of them do operate these incinerators, and they use the garbage as fuel, as an alternative fuel source, to generate electricity. So this kind of shows how these incinerators actually work. And the more modern ones actually have special scrubbers and filters on the stacks to try to eliminate a lot of the air pollutions. What they do end up with left after they do incinerate all this garbage is basically ash. That's sometimes called fly ash. And that will then be disposed of in a landfill. So that actually gets taken off and hauled away to a landfill. So when we look at industrial solid waste, this is all of the things that factories and mining and agriculture and petroleum industry, all of those kinds of waste products that are made through those kind of activities. And some of the methods are kind of similar to what a sanitary landfill is, but there are there are definitely some other strategies too. So this is a little cool video about how kind of using industrial ecology, breweries are able to take waste products from the beer brewing process, and they can actually make it into all kinds of other products, and including feeding pigs and all kinds of things. I've actually bought some dog treats before from some breweries, and our dogs really love to eat those. So there's a little YouTube video you can watch, and that's called industrial ecology, when things are sort of recycled within the industry itself. That kind of shows you a bag of mushrooms that are being grown on some of the waste products from the brewery. And so that's really interesting how they've done that. And there's a big upswing of breweries, microbreweries, all over the world right now. And so this is a good way of using a lot of those products. So let's talk about what hazardous waste is. And I think I've already given you the definition of this before, but by EPA, it means that it has at least one of the following characteristics. So it can easily catch fire, so it's ignitable or flammable. It's corrosive, so meaning that when it encounters metal containers, it can actually corrode those things. It's reactive, so sometimes they can chemically combine and react with other substances, or they're toxic. And if we call something toxic, that means that it's harmful to human health when you inhale or you ingest or if you touch it. So if it causes a problem for people, then we use that kind of generic term and we say that it's toxic. So there are lots of different things that even you encounter in your daily life. I'm guessing if you are at home and you go and you look maybe under your kitchen sink, or if you have a garage, you start looking around, you are going to find a lot of these things that are classified as hazardous. So paint, batteries, oils, solvents, cleaning agents, oils, lubricants, pesticides. All of these things are considered to be, quote, hazardous. Things that are not hazardous include all of these. So radioactive waste, household waste, mining waste, oil and gas drilling waste, liquids that contain organic hydrocarbons. So again, those are things that are left over from oil combustion. All of those are not classified as hazardous, although most of us would see radioactive and go, well, that's hazardous. But it has a separate category. It has a separate classification. It's not listed under this. Organic compounds and heavy metals are a huge concern. A lot of these things are toxic because they can actually be absorbed through your skin, and they can act as a mutagen to actually cause your DNA to mutate. Some of them are carcinogenic. Some of them are endocrine disruptors, and they can cause all kinds of issues. And they are persistent, meaning that they do not break down easily. And a lot of these things, like these heavy metals like lead and mercury, they're actually fat soluble and they break down really slowly. So they tend to bioaccumulate and biomagnify. And a long time ago, if you remember the diagram where we kind of showed how biomagnification works, and there was the old guy and the kid sitting there fishing, and how mercury actually biomagnifies in people. Whatever you have inside of you, that's what you're always going to have. There's no way to get these things out of you. So it's really important that we limit your exposure and that you don't come in contact and you don't ingest them to start with. A while ago, I had you watch a video called E-Waste Hell. And e-waste has certainly grown. This includes all of the old computers you've ever had or electronic devices, cell phones. Most of these things end up in landfills or end up in incinerators. Very, very few of them actually get recycled. And that's a shame because there's a lot of very important minerals and things that are in those electronics that could be recycled. This little figure shows you that every day Americans throw away about 350,000 cell phones. Oh my gosh, that's a lot of cell phones. So the EPA is now, and several states are actually beginning to sort of treat these things as hazardous waste. And the good thing is that a lot of these devices have become a lot smaller. So, and then some people are actually recycling them. Even your older electronic devices now, lots of times you can turn those in and get a few dollars when you upgrade your phones. You can trade them in. And so there has been an increase in recycling. I think people are trying to do the right thing and being more careful about it. The trace metals and things that are actually in here are valuable, and this shows you some Olympic medals from the 2010 Olympic Games, and some of these were partly made from precious metals that were recycled after e-waste had been discarded. So I think that's kind of a neat way of looking at those things. So let's talk about hazardous waste disposal. And there is a federal legislation that controls this, and that was called the RCRA, and that was enacted in 1976. And that's a comprehensive program for requiring rigorous testing and management of all the toxic and hazardous substances. And this accounts for something called cradle to grave accounting, where all of these materials have to be accounted for their entire use, and then once they're not being used anymore at the time of disposal. So the EPA estimates that the U.S. industries generate about 265 million metric tons of officially classified hazardous waste every year. That number's probably gone up. At least 40 million metric tons of that is toxic, and some of those things are actually released into the environment every year. So this sort of shows you the idea about cradle to grave accounting, and you see paperwork here, and people who have to deal with this kind of paperwork say that this is a very burdensome law, that it requires a tremendous amount of their time to keep track of everything. But it's really the only way that people think that they're going to be able to actually account for all of this material. Where is it all going to go? And this way we make sure that it's tracked and that it ends up being properly disposed of, and it doesn't end up being just dumped somewhere because these things are hazardous. So there's a federal law that is super interesting. This is what generated something called the Superfund sites, and this is aimed to rapidly contain and clean up or remediate if there are any abandoned toxic waste sites. And so this is called the CERCLA law, and it really does require manufacturing facilities to report on over 300 different toxic materials that they might be using as part of their industry. Government does not have to prove that anybody violated a law, or they don't have to even prove what role they played if there is a Superfund site where there have been hazardous materials. Let's read the law carefully to see what it actually says. The liability under CERCLA says it's strict, joint, and several. And what that means is that anybody associated with a site can be held responsible for the entire cleanup cost. So if one company buys another company, and then that company decides to close down in the future and wants to sell that land, if there are hazardous materials found on that land, then anybody associated with ever doing business on that land, even the former owners, all of them are responsible for the entire cleanup cost. And so this is a pretty strict law which is imposed, and this was a way of getting around the idea where people would just say, oh, I didn't dump it, it wasn't me, we didn't do that. And so this says that everybody who had anything to do with that site is actually responsible. So there are about 36,000 seriously contaminated sites that are in the United States that have been designated as Superfund sites. By 2000, about 1,551 of those had been placed on a national priority list for cleanup. That Superfund is a revolving pool of money, and it's designated to provide some kind of immediate response, if an emergency response, if there's some kind of all of a sudden, let's say a railroad car. There's been an incident and a railroad car overturns, and that tanker on the railroad was full of toxic material. People don't have to wait around to try to figure out, who to call and who's going to pay for that. The Superfund money will immediately be used to try to contain that kind of damage that before that hazardous waste escapes into the environment. This money is also supposed to be used to help clean up abandoned or inactive sites. And I've actually worked on 2 different Superfund sites before. They're kind of scary to work on because you don't really know what's been dumped there. The total cost to clean up all those sites is estimated between $370 billion and $1.7 trillion. So that's a big problem. There's not that much money available in that fund to clean up all these sites. At the very beginning of this, most of the money was being spent on lawyer fees, legal fees, especially companies trying to get out of, having to clean up these sites. But that has really changed quite a bit. Now the money is actually being spent on trying to reclaim and remediate these. One of the studies of where these Superfund sites, where they're actually located, it shows that a lot of these sites are very close to minority neighborhoods. And that would be a case of, environmental justice, where it's not right to have these kind of dangerous sites located near only poor people neighborhoods, right? We talked about that a long time ago too. And so there's another category which is a little bit less severe than a Superfund site, and these are called brownfields. These are contaminated properties that are abandoned or they're not being used currently. And lots of times the reason they're not being used is because they're worried about a potential for pollution. Up to 1/3 of old commercial industrial sites that really kind of make up the urban core in a lot of cities fall into that category. And so the question is always, how clean is clean? A lot of the people who actually own this say that the soil doesn't have to be that clean. And so who sets the standards? That's a question that people are constantly going back and forth about. And so usually it depends on what kind of contaminant it is. Usually there's a lot of soil and water testing of those areas before those areas can be sold or used for other things. So this video talks to you about something that happened a long time ago called the Love Canal. And there's even been a couple of movies made about the Love Canal. This is a really good example of what happens when these toxic materials are not disposed of properly. So I'd like you to watch this short video about the Love Canal so you have an understanding of what happened. Really, having the Love Canal, having all of this happen was really the beginning of starting the Superfund site. How does a small community or even a state go about paying to clean up some of the things that have happened in the past? And this shows you that one of the side effects of some of these contaminants are birth defects in children. And that's just absolutely horrible to think about that happening. And so this is sort of, a review of what happened with the Love Canal. You can watch the video where you can read through these slides and see how this all happened. There were a lot of homes built in this area after these materials were not disposed of properly. And a lot of complaints from the residents were early on were ignored. They could smell chemicals, and kids would even have chemical burns on their skin after they would be playing in playgrounds or playing in the yard. And it didn't take very long for a lot of these chemicals to start leaking. Again, these were improperly disposed of in the first place. People found chemicals coming up into their gardens and into their homes. For an example of, what can one person do? There was a local person who lived there. Her name was Lois Gibbs. And she really started a campaign after so many children started having all kind of unexplained illnesses. And she formed the Love Canal Homeowners Association. And this was a total volunteer grassroots organization. They had to collect data. They had to work with the EPA, would sometimes actually work against the EPA, because back then a lot of these reports were not made public, and so they had to really fight with the government to make sure that these reports, they could actually look to see what was in the soil, what was in the water, what was in the air. And this group really helped to spur that federal Superfund designation and get that legislation passed. So what's happened then? So the state actually closed the school. They purchased over 2,000 homes. The ones that were closest to the landfill, they purchased them from the people who owned them, and they moved away. A couple of years later, this whole area was considered to be a federal disaster area. They actually bought all the remaining properties that were left. Another 564 homes that were nearby were purchased, and people moved. And so this area just kind of ended up being abandoned during the reclamation process. And, because things were never disposed of properly in the first place, rather than digging everything up and then trying to figure it out, they decided to try to cap it with clay, and then they added some monitoring wells. There were a lot of chemical companies who had operated here were sued. They ended up paying a $98 million settlement and to help pay for some of the cleanup. But this was very difficult to try to pick any individual chemical and say that chemical caused these health effects. And so this whole area really remains a big question mark. In 1990, the EPA actually said that some of these areas were actually safe now, and they began selling the homes at a big discount. And so they let some of the people move back in. But again, remember, this dump had never been cleaned up. They just added a drainage system and a cap to it. And they do acknowledge that this might leak again. And so anybody who buys a home there has to sign an agreement that there are safety issues with living near the site. But a lot of those homes are still being purchased now. So there's a sign that shows, that this is that's the old school that used to be there. And this is a hazardous waste area. So remember, we can't ever really throw anything away. That waste don't stay put, and preventing pollutants from entering the environment is much, much cheaper than trying to clean it up after the fact. That's really the moral of the story about the Love Canal. And so what are some of our hazardous waste options, right? One, produce less waste. So avoid creating these wastes in the first place. Recycle and reuse. A lot of industries are converting to less hazardous substances. They're doing physical treatment or incinerating on site. Sometimes they're actually using different chemical processes to transform some of these materials. And then lastly, bioremediation, the idea that microorganisms can help to break down some of these things into less hazardous systems. So that's sort of how we're dealing with it now. Now, some things are so hazardous that they have to be stored permanently. And in that case, they will have some kind of retrievable storage. So every once in a while, they can go and inspect and make sure that nothing is leaking. And then another idea is to have these secure landfills. So they're very similar to modern landfills like we watched the video about. But these secure landfills will have multiple liners, and they'll have a lot more monitoring systems to make sure that nothing escapes the site. This is what one of those secure landfills looks like. You can tell that there's a lot different kind of cells here. They add clay and liners in between them. They do have a testing well going down in there to make sure nothing is leaking. And so that's what a secure landfill looks like. There are not very many of those operating, and they cost a lot more money to run and to be able to dump materials there than a sanitary landfill. So these are much stricter about what kind of materials go into a secure landfill. As far as burying the waste, that's what's done with a sanitary landfill. Back at the beginning, I kind of showed you the video about how those run. Remember that as all these waste products break down and start to decompose, two greenhouse gases are released, carbon dioxide and methane. The methane is usually trapped in a well, and then that can be used as a sort of form of energy of natural gas. The carbon dioxide, however, is usually released. So that's a problem with burying all of these things. And then we need a lot of space to be able to run these landfills. They take a lot of room up, and there's not always space available near a large city. The land is too valuable, and there's not enough room to operate one of these near a lot of different cities. Some folks think that some of these really hazardous wastes should be injected in these deep wells. So if there has been a maybe drilling in our areas, this might be an advantage. So if there's already been oil and gas well drilling and we have these deep wells, we can inject them down into the well. It's possible that those wastes then could be pumped out and retrieved in case there is a problem. And this is very inexpensive. This is very low cost to be able to get rid of things like that, like this. The disadvantages are on the right? There's lots of chances for leaks or spills. The case of the well could actually start to leak or corrode. And if there's any earthquakes or fractures, it's possible that some of those wastes then could escape into the groundwater. And this really encourages a lot of waste production because of how cheap it is. And so it's kind of the opposite of what we're trying for, where we're trying to minimize and reduce how much waste are being produced. This is a picture of a hazardous waste landfill, so you can kind of see that again. It's kind of like the last one that I just showed you. In this case, you can see there's a double leachate collection system just to make sure that nothing leaves the landfill. There's also a double liner. The other sanitary landfill only had a single liner. So lots and lots of different kinds of compounds that have been put in here, and they usually will bury things in certain containers that are supposed to not be very reactive. A lot of monitoring that goes on with these kind of landfills for sure. This is an above ground one. This would be for hazardous waste, and we're not exactly sure where we're disposing of it yet. So lots of times they're stored here for a short while. They can be retrieved and then stored somewhere else later on. And so that's just an above ground version of that. And so that's the end of our last lecture. This is the end of the lecture material for the final exam. So I would encourage you to go back and review how these landfills actually operate. There's a couple of videos there that we didn't watch during this talk that I would like you to go back and watch. And that's it. Please let me know if you have any questions about anything, and I'll try to be able to answer your questions. All right, thanks everybody. Bye-bye.